Assalamu alaikum, welcome Mahbub, welcome back. Today we'll focus on the Newton first law, but at the beginning let me to ask you some question about forces. We still talk about force acting on the object, and all this chapter we will speaking about the force acting on the object. Now suppose that we have two objects, the first one at rest and the second one move in constant speed. If I asking you a question, which one the total force acting in this object will become zero? Most of you think that to be at rest, the total force will become zero, but it's misconception. In fact, both of them, the net force or the total force acting on them will become zero. How it's happened that we will focus on all this information in this lesson, Newton first law. To understand that, guys, suppose that we have an object or box and we will move and push this box on the carpet. Now suppose that we will push this object with the force, in this object, and we will move the object or push the object on the carpet. I think that the object not move further, not move a lot. It will just move for 2 or 30 meters. Why? Because this carpet have very big fraction and this object can't move in the carpet. But suppose that the same object and we will push the same object with the same force. Now this object now will move further on the ice. If we push this object on the ice, now the object will slide farther, farther than the first one. Why? Because the ice no more fraction, very low fraction. Suppose that we have here surface, perfect surface without any fraction. Suppose that, of course, we do not have any surface without fraction, all surfaces without fraction, but maybe the fraction will be less or more and like that. But anyways, suppose that this object, we will push this object with the same force, now you can see that the object will move and don't stop. Now if we have perfect surface, the object will move forever. That is the Galileo rule. The Galileo said that or concluded that. Look over here. Now Galileo said that the object want to be maintain its state of motion or rest, do not need to change its state. Want to be move every time, like this object here. If we have, the scientists, guys, set some rules. He said that if we do not have any fraction, if the net force equal 0, now the object stay in motion and also the object stay in rest. Now the Newton said that again and complete to explain more about the Galileo rule. Said that the Newton first law said that object at rest, it will be at rest. Object in motion, it will be in motion in constant speed in straight line, but unless object experiences a net external force. It means if the external force acting on the object equals 0, the object stay at rest and the object in motion stay in motion. Now as you saw here, if we do not have any force acting in the object stay in motion forever. Because that, guys, if I asking you again about this question, now if we have object move in constant speed or at rest, both of them, the total force acting on it equals 0. Also, guys, this Newton first law sometimes named as inertia, law of inertia. They are the same. What is the inertia? Inertia is a tendency of object to resist its motion. To resist its motion, do not need to change its motion. The same thing Newton's first law said that also, because that sometimes they called the Newton first law is law of inertia. Now if we have object and this object in motion want to stay in motion. I will give you an example. Suppose that you are in the car, and the car move. Now you are now for the earth, okay, or relative to the earth, you are in motion. You are not in rest now. Relative to the earth, you are in motion. Okay, now suppose that, okay, the car stops suddenly. What will happen for your body? You can feel that your body want to get out from the car. Okay, do you know why? Because you was in motion and you want to stay in motion, because that when the car stops suddenly, you want to complete movement. Okay, because that if you don't use this here, I mean the seat belt, if you don't use the seat belt, it will be a very big problem when you stop suddenly or accident. Okay, now that is the inertia. I'll give you another example. Suppose that we have coin like that, okay, and we have paper, and we will put the coin here like that. Okay. If you move the paper quickly back, now the coin will move down in the cup like that. Why? Because the coin was in rest and want to stay in rest. When the paper move, the object do not need to change its state, do not need to stay in rest. It want to be stay in rest, because that coin will fall down in the cup like that. That is the law of inertia. The same thing with the Newton first law. But guys, the most important point, the rule for this inertia, for this Newton first law, the rule is when the external net force for the object equals 0, if we do not have any forces acting on the object, or the object move in constant speed or in rest. Both of these cases, the inertia, we have inertia and we have Newton first law, and the external net force, it equals 0. Okay, and when we have object move in constant speed, it means no acceleration. It means the object will will have the Newton first law and inertia. But the question is, what the difference between external force and net force? External force, it will become the single force acting on the object. All the single force acting on the object. Suppose this car here, look over for this car here. Now we have gravitational force and we have a normal force, and this car will move forward, and we have resistance. All of single one of these, it will become the external forces. But this car net force equals 0. Net force here, it means the vector of sum for all forces acting on the object. Okay, the sum of all forces acting on the object. Okay, let me to give you another example to understand more about the difference between net force and the external force. Okay, suppose we have here the object, and I will move this object in this direction by 60 Newton, and another one will pull this object in this direction by 30 Newton. Okay. Yeah, now where this object will move? Okay, move here or move there, it will move like that. Okay, that is the net force. Now 60 Newton, it will become external force, and also 30 Newton, it will become external force. But here, this is a net force. Okay, now the total sum of this one, it will become net force, and we will explain some problems about that to understand more about how can we realize and how can we count the net force. Okay, now but what is the relationship between inertia, okay, inertia, and mass, and also acceleration? What the relationship between all of this? Okay, the inertia, it will become the scale of the mass. It means we have a direct proportional between inertia and mass. What does it mean of the direct proportional between the inertia and mass? Suppose that we have here object like that. Suppose that we have bowling ball, and of course bowling ball will be very heavy, and we have another object that is the basketball, for example. Okay, of course the bowling ball will be very heavy, and we will exert for both of them by the same force. Okay, by the same force. Of course this bowling ball not move a lot because this one very heavy and the other one move more or move further. Why? Because this one lighter. Now the mass, it will become the scale of inertia. When we have more mass, more inertia, and less mass, less inertia, and inversely proportional between mass and acceleration. When we have more mass, less acceleration. When we have less mass, more acceleration. We can make it like that, guys, to understand more. Okay, now that is the inertia. Okay, we have direct proportional between inertia and mass. Okay, this symbol, it means a relationship. Okay, now that is the inertia and mass. We have direct proportional. More mass, more inertia. Less mass, less inertia. Okay, but in other hand, inversely proportional between mass and acceleration. Okay, acceleration. Now that is the inversely proportional. When we have more mass, less acceleration. Less mass, more acceleration. That is the relationship between inertia and mass. Now we can say that the inertia or the mass, it will become a scale of the inertia. It will be very important to understand about inertia when we know the mass, because that this object heavier have more inertia, do not need to move. Okay, but the other one, low inertia, it will move easily. Okay, that is the scale of the inertia. Mass is a scale of the inertia. Okay guys, now as I told you, when we have object, okay, when we have object move in constant speed, or object in rest, okay, both of them, the net force equal 0. Okay, someone told me, mister, there are another forces acting in this object, and also here we have another forces acting in this object. We have gravitational force, we have a normal force, and like that, and also here we have fraction, we have another things. Yes, you are right, but the total force acting in the object, the net force acting in the object, it equals 0. Okay, if you look over here, now the total force acting in the object equals 0. Net force equals 0 because this one is stable and this one also stable. Now this constant speed, it means no acceleration. It means all of the total forces acting in this object, it will become 0. Now for both cases, the net force equals 0. If we have object like that and the total force equals 0, we can say that the object will become in equilibrium. Equilibrium, it means the state when the net force acting in the object, it will become 0. Okay, and it will become in two cases: rest, the object rest, or the object move in constant speed, and like that, guys. In general, if the net force equals 0, now we have equilibrium state of the object when the net force equals 0. Okay, look over for these diagrams here in your book. You can see that here we have 3 pictures. Where is that? If you look out for these 3 pictures for this man here fishing, you can see that which one the total force equals 0. Okay, you can see that all of them, the total force equals 0. Why? The first one here, this pop in rest. Okay, now in this one in rest, the total force equals 0 because this one in equilibrium. Now what about this? When he hunt the fish and now the fish move in constant speed, it means A, acceleration equals 0. It means the net force also equals 0. Okay, because that this also this one in equilibrium. Okay, what about if this man exert in the opposite direction for this one, okay, in opposite direction for this one, the same force, suppose this one exert by 20 Newton, and he will exert by the same force but in opposite direction. Now also we have the net force equals 0, because that this one also in equilibrium. Okay, because that, guys, if we have any object and if this object moves like that, suppose that in 100 Newton, okay, now, and we want to be this object in equilibrium, we should to make the net force equal 0. Now we will exert in this object in the opposite direction by the same force. Okay, now this object in equilibrium. Okay, that is the simple rules of the Newton first law. Let's explain some problems to understand more about how can we answer the problems about the Newton first law. For this problem here, this is a simple problem about the book, and this book will slide down of this table. Okay, now let's draw this free body diagram for this one. Okay, now this table angle here, this is the 35 angle. Okay, I will make it bigger like that. Okay, that is the 35 angle of this table like that. Okay, and the book will slide down. Okay, now that is the free body diagram for this book. Okay, now the book will move like that. It means the net force, it will become in this direction. Okay, now he gave you that the gravitational force, it means the weight of this book, it will exert in this direction every time. Okay, it will become 22 Newton. Okay, that is the Fg. What about normal force? The normal force should to be perpendicular to the surface. We like that. Okay, 18 Newton. Okay, and we have fraction to become like that, 11 Newton. Okay, now that is the net Fn, it means normal force, and here we have the fraction F. Okay, 11 Newton. Okay, now he wants to find the net force for moving of the book. Okay, now that is the problem. Let's see how can we answer this problem. Okay, guys, now at the beginning, as you see here, now we have angle 35 degrees. Okay, and this one is perpendicular like that, and this one, it will become 55 degrees. Okay, now you can add 90 with 35, negative 180, this one, it will become 55 degrees. Okay, now at the beginning, guys, we should to determine the coordinate system. The coordinate system here, guys, it will be like that, that is the x and that is the y. You should to determine the coordinate system. It's a very important point. Okay, now that is the x and that is the y. Okay, and here it will be the positive x, and this one, it will become negative x, and here that is the become, here it will become negative y, and the other one, it will become positive y. That is the coordinate system. It will be easier to understand. Okay, now let's use the vector operations to deal with this one. Okay, now we have here a vector on the x, there are no problem for this one, and also here another one on y, there are no another problem, but the problem with this vector and with angle. Okay, this vector with angle, we break this vector into two components. We will break this vector into two components. Okay, now we have in x-axis and in y-axis. Look over for the angle with the x or the y with x. When the angle near of x, we will write cosine. Now we will write like that, 22, that is the x, guys. Okay, 22 cosine 55. Okay, that is the x, and y, it will be away from the angle, because that it will become sine. Okay, yeah, it will become also 22 sine 55 like that. Okay, and after that we will make table for x and y. Okay, now which one do you have in x? We have negative 11, and we have positive 22 cosine 55. Okay, and here in y we have 18 positive, and we have 22 sine 55. Okay, but this one negative. Can you see that here? Negative. Okay, yeah. Now and now we will find the cosine for this. It equals, if you make it by calculator, it equals 12.6, and this one equals 18. Okay, now now take the sum for all. Now negative 11 plus 12.6, it equals 1.6 Newton. Okay, and here 18 negative 18 equals 0. Now use the Pythagorean theorem to find the net force. Equals square root 1.6 squared plus 0 squared equals 1.6 Newton. That is the net force for this one, and this one will move downward in this direction. Okay, that is the problem of the Newton first law, and we have a lot of problems in your book. You can make revision and you can answer all of these problems. If you still have a question about the problems in your book, page 125, you can ask me in comments, or you can ask me in WhatsApp. Thanks a lot for listening, guys. I hope you understand. Thanks for watching. See you next time, inshallah. Assalamu alaikum.